Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, sets. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any question about what we see today, or even on homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 10th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video should be a rather impactful one with 6 wonderful parts, so make sure you stay tuned, leave a like, and smash the subscribe button. Now, let's get started. So today we're going to be talking about sets, but unlike my earlier videos in which we covered the union of sets, the intersection of sets, and even complements of sets, we're going to be focusing on the basics, going back to the basics. And what I mean by that is we're going to be looking at what goes on within a set and how we're going to denote that mathematically. Now, if you hadn't seen any of my earlier videos on sets, you can find them right up here. But as a quick refresher, a set is going to be a group of pretty much anything. It can be a group of numbers, letters, words, anything you can imagine. A set can even be a group of nothing. We actually have a set of nothing. This is called an empty set. It has nothing in it, but it's a set of nothing. A set can literally be a group of anything. Sets can also be finite or they can be infinite. It depends on the set. There's a lot that goes on for our sets, but how do we talk about the things that are inside of sets? Let's say we have this set here. So we have this set A that has 1, 2, 3, 4, and 5 in it. This is the entire set. How do we talk about these things inside the set? How do we say that 5 is in this set A? And of course, we don't want to have to write a sentence for each and every one of these. How do we denote that mathematically? So if you want to say that 5 is in this set A, you would just say 5, put this symbol here, this E-type symbol here, and put your set name. The name is A for the set. So 5 is an element of A. That literally means that 5 is inside this set A. And so you don't get confused, this looks like an E, so when you're talking about elements within a set, you're going to be having this E-like symbol. And you can do that for everything inside this set. So you can say 1 is an element of A, 2 is an element of A, 3 is an element of A, and of course 4 is an element of A. This is how we're going to denote things within a set. You have whatever that is inside the set, you have this E-type symbol, and you have the name of the set. But let's say we have something like this, where we have 2 sets. We have set A and set B, where set A has the elements 1, 3, and 5, and set B has the elements 1, 2, 3, 4, and 5. How do we denote a relationship between these 2 sets? Well, we notice that set A has 1, 3, and 5, and those are also in set B. So do we say that A is an element of B because of that? No, we don't say this. If we want to say that A has all of its elements within another set B like this, we would actually denote it this way. We would say the same A, and instead of having the element notation, we would have this C here. It looks like a C. It's not quite a C, but it looks like a C. And then we say B. So A is contained, C contained in this set B. And if this is true, we would say that A is a subset of this set B. A is a subset. So if B is your set, a smaller portion of that set is going to be A. A is a subset of this bigger set B. However, there are 2 types of subsets. We have 2 different notations for our subsets. We can have the notation I just showed you, that, or we can have something like this. And they have different names. This right here is called a proper subset. And this you would just call as a subset. So what's the difference between a subset and a proper subset? Well, if you was to say A is a proper subset of B, like this, what you're really saying is everything in A is in B. However, A does not equal B. There are elements in B that are not in A, which that's the case here, right? We have 1, 3, and 5, which all exist in B. However, A doesn't have 2 or 4, so it doesn't have the equals portion to make it just a subset. A is going to be a proper subset. But let's say you had a C here, right? C, which was 1, 3, and 5. We can say that A is a subset of C because A, 1, 3, and 5 all exist in 1, 3, and 5 C. And there are no elements in C that's not in A. So we can say that A is a subset of C. It's not a proper because there aren't any elements in C that are not in A. Once again, a proper subset means it's strictly contained. There's no chance for an equals. A subset means that it can be equal. It doesn't have to be equal. It can be equal. There are times where we're not sure if it's equal. But if we're a little bit more flexible, it can be equal. That's the notation you're going to use there. If it can be equal. If you're saying it cannot ever be equal, it has to be strictly contained. It has to be just a smaller portion of the larger set. You want a proper subset. So if we wanted to write a definition for a subset using our element notation, and we want to say that A was a proper subset of B in this case, we would say that for every element X in A, X has to be an element of B. However, there exists some element Y in B that is not an element of A. So for every X in A, X has to be in B. But if it's a proper subset like this, that means there's some Y in B where Y is not going to be in A. Now this leads us to our next point. How do we denote mathematically a negation of the notation that we have been talking about, whether it be this E element or this C containing this subset? How do we denote a negation of these notations here? So let's say we have this set A that has 1, 2, 3, 4, and 5 within it. And we want to say that, well, 6 is not an element of A. What do we have to write without having to write more words and symbols? What do we have to write to denote that 6 is not in this set A? Well, you're going to start with your element, right? Because we're talking about something in the set. So you start with this element, and then you're going to put that bar there. This diagonal slash through, we're going to put that, and this is going to denote not in A. So this 6 is not in A. You can say that 7 is not in A. Anything that's not in here, you can put that symbol. That's how we denote that something is not in a set. So we negated elements, but how do we negate subsets? How do we say that something is not a subset of another? So let's say A is not a subset of B. What do we put here? Well, you would just put the same C, right? Because we're talking about containing, right? Subset. This is not contained in B, right? So we would say the same thing with that same type of bar. Remember, we're not going to be using the E notation here. Remember, this is set A, and we're trying to say that every element of A is not in here. Every element of A is not in here. So A is not contained in B. Now this might be a little bit too obvious because nothing in A is in B. But let's say you had something a little less obvious. Let's say you had something like this, where you said 1, 2, 3, 5, 6. This is still going to be true. A is still not going to be contained in B because remember, the definition said every element in A has to exist in B for A to be contained in B. You have an element here that's not in B. Therefore, A is not going to be contained in B. So it doesn't matter if you're missing all of the elements or even one of the elements. As long as you're missing something, you are not fully contained in B. So therefore, you can put this notation. And notice that you don't necessarily have to do this, because if it's not going to be a proper subset, is definitely not going to be a regular subset because this is just allowing equality. Well, if you're not even contained, you don't have any chance of being equal. So if it's not going to be a subset, you don't even have to write this to start off with. You can just go straight to your C and cross it out, as we did here. And clearly, B is also not going to be contained in A, right? There are some things in B that are not in A. The 6 is not in A, therefore it's not going to be fully contained in A either. A is not going to be contained in B, neither is B going to be contained in A. These are not subsets of each other. Now, I debated with myself whether I should even cover this portion of the video, and that's because what I'm about to show you may be a little confusing. However, I figured I wouldn't be doing you a service if I didn't at least mention this, because you may leave where you are now, this school, this class, have a different teacher, or even a different textbook. And you may run into other types of notation that's slightly different, and I don't want you to be thrown for a loop because you've never seen this other notation. So we're going to be covering some other notation that you may see for subsets and proper subsets. So we said that this is your proper subset. This is a proper subset. It doesn't allow for equality. And this is going to be your subset. So this does allow for equality. However, depending on, like I said, a teacher, a textbook, a school, a class, you may have another form of writing this. Instead of having this C here, because C can be interpreted in different ways, they may explicitly write out something like this. This is also going to be a proper subset. And what this says is it's contained, but definitely not equal. So because some people may say that this can allow equality, they want to denote that it's definitely not equal, while this one can be equal. So you may run into this pair, or you may run into this pair. But I want to let you know that depending on the context of your textbook or whatever you're learning from, this is going to be the same as this. If this is a proper subset, this is going to be another way of denoting that you may see in a different flavor. Now I want to go back and cover something that we mentioned briefly earlier in this video. We said that we didn't want to write this. A is an element of B. We wanted to say something like this. A is contained in B because these are two sets, and we want to say that every element in A was going to be in B. And we said this is not how you do it. This is how you do it. But I want to ask you, is there ever going to be a case where this is indeed true, where we're saying that the element itself is an actual set? Well, yes, this is definitely going to be true in some cases. But what does this look like? This is what I mean by a set is an element in another set versus a set is contained within another set. If you have a set A where you have 1, 2, and 3 as your elements with an A, and you have a set B where you have 1, 2, 3, 4 is going to be within B, you would say that A is contained in B. This is a proper subset of B. However, if you want to say that A was an element of B, this is not going to be true. If you had something like this, in order for A to be an element of B, the set itself would need to be inside of B. Notice we have this big set, and one of the elements is the set A. This is going to be the case where A is an element of B. It is not enough to have all your elements here. You have to have the actual set. And remember, I said your set can contain anything. You can have sets within a set. So this isn't far-fetched. And you can have more than one set. You can have something like this. You can have 1, 2, 3 in that set, and you can have another set that just has 1 and 2, and you can have something like that where you have a set of 2 different sets. It doesn't matter how many sets are in here, as long as this particular set is in here, you can say this set is an element of this other set. So these are going to be our final examples for today, and I want you to fill this in as best as possible using everything that we learned today. That means that you may have more than one thing you can put in these blank spots. I want you to fill them in as best as you can using everything that we talked about. Fill this in on your scrap paper, and I'm going to give us the answers, and we're going to see if we matched up. So pause this video now and hit play when you're ready to see the answers. Well, welcome back. And here are all the answers. Let's check to see if you got the same thing that I did. So 1, we have the set B and A. Based on what we have up here, we see that B is going to be a proper subset of A. It's proper because it doesn't equal A. There's an element 1 that's not in B. So it's a proper subset of A. However, it's not an element of A. This is not fully contained in A as a set. So it's not an element. It's going to be contained, but not an element. Contained, but not an element. Let's move on to 2. We have the set A and C, and we want to see what's the relationship between them. Well, if this is A and that's C, A is neither going to be an element of C, nor is it going to be contained in C. So it's not an element and not contained. Let's move on to 3. We have 2 and B. Well, if that's B, 2 is going to be an element of B. Now you may be asking, how come I didn't say 2 was not contained in B? Well, in order for you to be contained or have that notation, you have to be a set. 2 is not a set by itself. 2 is just an item. So we can't say or use the subset notation because 2 is not a set. If you have braces around it, it would be a set. But 2 in itself is not a set. You only need to worry about the element notation for this type of situation. So 2 is going to be an element of B. Let's move on to number 4. We have A and D. Well, A is not going to be an element of D because this whole set is not in D as a set. But every element in A is in D, and every element in D is in A. So this is going to be a subset. So it's not an element, but it is a subset. Not a proper subset because it is equal. Moving on to 5, we have 3 and A. So 3, the item 3, is not going to be in A, so we have it's not an element of A. Once again, for the same reason, you're not going to use any kind of subset notation because 3 is not a set. So let's move on to 6, B and C. If that's B and that's C, we see that B is an element of C. All of this whole set is inside C. However, B is not contained in C. There is no 2 here by itself. Every element in B is not going to be in C. You would need to have a standalone 2, not the set 2, for you to be contained in C. So for this one, it's an element, but it's not going to be contained. B is not a subset of C. So these are going to be the answers that I got, and I hope that they match what you got. However, if there was anything off with what I did and what you did, let me know what happened in the comment box below. So I hope you were able to follow along with today's examples, and I hope you now truly grasp the basics of your sets. However, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. That's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.